Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Happy Thursday to you all. Hey, I've got good news for you, and I've got good news for you, and I've got further good news for you. No bad news? Nope, no bad news. I thought we had a test tomorrow. Wouldn't that be bad news? Nope, because I'm going over the topics, and you are going to have to work really hard to not get a good score. I mean, the ball is going to be in your court, so to speak. Okay, now, you got to do your part. So your journal's out, right? You ready to write in it? A big shout out to some new RLO customers. Welcome to RLO, Remote Learning. Now, you people in RLO, you've got to be extra. I gave this speech earlier to some of you. You've got to be extra conscientious about paying attention, lock in, and also taking notes in your journal on the key points. I'm going to tell you what topics I'm going to test you on tomorrow. And then I've got a few new things, and it's going to be cool. It's going to be interesting. So anyway, we're going to write in our journals. So, and by the way, okay, I guess this could be potentially a little bit of not so good news. I am going to check your journals probably at a halfway point this quarter. So you better be writing in them. I'm going to collect them, and they're going to be worth 20, 25 points, like a test. Like a test score. So be writing in them. Now, tips really quick for writing in your journal. Abbreviate. Don't write every word. So abbreviate and just write down the key words. Those notes in your journal are for you. So when I look at them, I'm not going to look to see if it's great writing or not. It needs to be relatively neat so I can see what you wrote. Now, what language is that? It looks like English. It better really look like English. So anyway, but just the key points, that's what I'll be looking for, okay? So anyway, so homework in your lesson planner is to study R tonight for your test tomorrow. R. If you review and review and review some more, you will remember and remember and remember some more. And that's good when you're taking a test. Like to remember? Oh yeah, that would be really good. So anyway, now let's see. I wanted to just to tell you a little observation thing. I was out in the backyard earlier today with the grandkids, and I was looking up at the clouds, and I'm going to ask you about clouds on the test, the kinds of clouds. Really quick, I'm going to ask you about stratus, the low layered clouds that extend a long way horizontally. I'm going to ask you about cumulus clouds, the puffy cotton ball kinds of clouds, fair weather clouds. They indicate clear weather, sunny days usually. But they grow. They can grow if there's a lot of moisture available that gets heated up and evaporated. They can grow, evaporate, and condensate into cumulonimbus clouds that can produce a lot of precipitation. Thunder, lightning, even tornadoes, which I'll talk about in a little bit. And luckily for us in Arizona, we don't have to sweat the really vicious weather that can be formed by cumulonimbus clouds. I'll tell you why in a bit. But to the clouds again. I haven't finished, have I? So cumulonimbus and then cirrus. The feathery kinds of clouds way high. Now today when I was looking, it was mostly cirrus clouds. They just looked like someone took a paintbrush and went, whoop, cirrus. cirrus. Now, I was also noticing today some clouds, and I'm going to ask you this. This is your first input into your journal on this Thursday. Will it be on the test? You betcha. So here's what I noticed. Some of the clouds had some condensation coming out the bottom. You call that virga. So you've got a cloud and you have precipitation coming out the bottom of the cloud. Virga, it's called. V-E-R-G-A. Virga. So it comes out the bottom of the cloud, but it doesn't reach the ground. So it's like it's raining way up in the air out of those clouds, and it doesn't ever get to us. Sometimes you see a lot of clouds that have virga coming out the bottom. I'll ask you that tomorrow. So you got your kinds of clouds. So you got stratus, you got cumulus, cumulonimbus, you got cirrus, and then virga sometimes coming out of those cirrus clouds, or even cumulus clouds that are up way high. So anyway, let's see what else. Hey, a quick reminder on class rules, just really quick. Mr. Phillip has reminded you of these, and I'm just going to go over them again. These are not options. You can't go, I think I'll choose not to do that. Bad decision. You don't want to do that. Okay? Mr. Phillips and I are going to be really tight, really tough on these class rules. So while Mr. Phillips or moi is talking, you ain't talking. No. So yeah, that'll get you a one-time reminder. No talking, warning, and then after that, consequences. So not following these rules, there'll be consequences. Probably find yourself in a new seating chart pretty quick, not where you wanted to be. So, not so good things happen if you don't follow these class rules. And Mr. Phillips is going to do a nice job of, shall we say, I like this verb, enforcing them. Yeah, enforcing them. So, and I guess I could probably even call him the enforcer. Yeah. So anyway, don't be talking while he's talking or I'm talking. No can do, because you're in an NBZ or an NTZ. No blurt zone or no talking zone. So, and next, no food or drink in the classroom except Wawa. Just Wawa, H2O, that's it, good old H2O for hydration purposes. Otherwise, don't be doing it. Okay? That'll get you in trouble. And then don't write on the tables. That's really a biggie. Say, hey, Mr. C, what's going to happen if I write on the tables? Not a good decision. What will happen? Here's what will happen. So if we find out there you end up being a writer, we'll relocate you in the seat chart. And then we might invite you to come in, say, at advisory, and we'll give you cleaning materials even. We'll be generous and give you cleaning materials, paper towels, and some Windex or something to wash off 6 to 8 of the tables. Really good. It'll take 10 to 15 minutes of your precious advisory time. I don't want to give away my advisory time. I know! So don't be writing on the tables. So there you go, class rules. Don't be talking while we're talking. No food or drink. Don't write on the tables. Okay? And then Bob's your uncle, as they say in Australia. Then it'll work out really good for you. It'll be a good day. So anyway, there's all of that. And then here are the topics on tomorrow's test. Mr. C, I'm thinking about, I'm going to have my journal out and make sure I've got these topics. Check, got that, check, got that, check, got that. Yeah, good idea. So here they are. John 1:3, you're going to write it. By the way, the verse sheet is up on Teams. It has been uploaded onto Teams. John 1:3, all things were made by him, and without him nothing was made that has been made. The meaning of that, Jesus made everything. He made all matter. He made every atom that everything is made of. So that's the meaning. I'm going to ask you a few questions about the Galileo drop, object drop from the Tower of Pisa. Yeah, that's the way it's pronounced. And then I'm going to focus on the variables. Remember, variable just means difference. The ones you keep the same are control variables. The one that you don't keep the same, the independent variable, like the different massed objects and therefore had different weights. So I'm going to focus on that. And you know that experiment, the different massed or weighted objects dropped at the same time from the same height on the same level surface. All of that can only be successful if it's done in a no air environment. That would be called a vacuum. That would be a vacuum where you suck out all of the matter, like on the moon. So that's where you've got to do that to make it work right. So, and then the outcome, the conclusion, gravity pulls equally hard on both of those objects. They fall to the ground at the same time. So tomorrow I'm going to show you that hammer and feather video. So I'll show that to you. Okay, really quick, I want to zip through the other topics. The intelligences, Dr. Howard Gardner's intelligences or strengths. I'm probably going to ask you for 4 of those. There's mathematical, logical strength, or math smart, art smart, music smart, people smart. We've gone over these. Self smart, you're just really paying attention to your feelings and into yourself. Nature smart, so really love nature like myself, just really into the weather and animals and plants and rock formations and everything in nature. That's me. Okay? And some of you probably. And you might not have discovered that yet, but you will. Body smart, you're really coordinated, probably going to be really good or are already really good at sports. So it'd be body smart. There's God smart. That would be exist. The idea of why do I exist? Where did I come from? Kind of what's my purpose? Existential, smart. So all of that. So I'm going to ask you the smarts. And then another topic, hydration. I'm going to ask you probably 4 good things that happen to your body when you stay hydrated. When you drink 6, 7, 8, 10 ounce cups or containers of water. So all of that. I'm going to ask you about your superpower that daughter Laura talked about. What's your superpower? It's who you are, the way God designed you uniquely. That's your superpower. Who I am with all my gifts and talents. So, and then the idea of why do you have a superpower? And the idea is to glorify God, to make God look good. And it's also to bless you, to bless God and to bless you. That's why you have your superpower. As you discover more and more who God designed you to be, it's going to be more and more enjoyable being yourself. Just figuring out, who God made me to be. And as you get older and older into high school and then your adult years, in your 20s, even in your 30s, it gets more and more fun to learn who you are. And you get to where you don't care what other people think about who God made you to be. Like, I don't care that I teach silly and goofy. I don't care. That's me. I love it. I love who God designed me to be. So, and you either are starting to or you will. So, it's really fun figuring out who God made you to be. Fun, fun, fun. Okay, and then the meteorology stuff, scientific study of the atmosphere, weather patterns, La Nina. In a La Nina pattern, we've already gone over this. In a La Nina pattern, we have warmer, drier air, and the jet stream is north of us and doesn't move storms from the Pacific Ocean over us much during a La Nina pattern. The El Nino pattern, we get the jet right over Southern California and right over Arizona, moving big blobs of moisture from the Pacific Ocean over us that condense and cause a lot more rain down here in the valley and a lot of snow in the high country, like late last year and late the year before. That's El Nino. So I'm going to ask you about that. So, and we need to pray, Lord, please turn our La Nina pattern into an El Nino pattern. We need it to top off those lakes. We're in pretty good shape from last year, but we need more. Okay, I'm going to ask you about kinds of precipitation: rain, snow, sleet, and hail, and then virga. Virga, that doesn't hit the ground, and it often is curved because the jet stream blows it sideways, and you can see moisture or rain coming out of the bottom of a cloud way up there, and then it gets blown by the jet stream and its path curves. So virga, you'll see that curved moisture path. So I'm going to ask you about the water cycle. Evaporation, evaporation, evaporation. You've got your ocean down there, a key component. So the water goes up, evaporation, then it condenses or cools way up high, forms clouds. Then precipitation, so evaporation, 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 condensation, 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 precipitation, precipitation, precipitation. Out the bottom of the clouds, rain, snow, sleet, like frozen rain, hail, big chunks of ice that fall out of those cumulonimbus clouds. So the water cycle is God's conveyor belt for moving water from over the ocean, over land, and then precipitating it out. The jet stream blows it over Arizona, and then it falls as snow in the high country, melts and runs off, so runoff into our lakes. Roosevelt, our biggest, and all the others. So that's the water cycle. So I'm going to take a quick break right now, and Mr. Phillip is going to let you really quick catch up on anything you've missed to date. And in your journal it goes, you RLO students, if you miss something, you can send me a little chat message. I'll see it. I'm all over chat these days. So send me a chat anytime. Mr. C, what about this or what about that? I'll get back to you. Okay, but I do want you to pay attention. That's your part. Okay, Mr. Phillip, little timeout, little catch up on anything you missed, and then I'll come back and talk about a couple other topics. Okay, here I am. I am back for the second half of our period. Okay? So, you RLO students, are you still zeroed in? Mr. C, what was that other good news? Well, the good news is, so I'm going over all the topics to get you ready for the test. Further good news is you're going to do well on the test. And then even more good news, no school on Monday. So a 3-day weekend coming up. And we can already see that 3-day weekend in our binos. So, yep, it's a coming. Okay, now, I want to point out something, and then I'm going to teach you another weather term. One of the reasons Arizona is so dry, here's why. We are in the shadow of the Sierra Nevada mountains, sort of. Mr. C, they're not that close. I know, it's a figure of speech. It's called a rain shadow. The area usually to the east of mountains that get a lot of rain or snow, or an area that gets a lot of rain or snow, like Seattle, Washington. They get a lot of rain in Seattle, right off the Pacific Ocean. But then on the other side of the mountains, there in western Washington, is the Spokane area and other areas. And the rain and snow falls on the mountains above Seattle, and there's not much moisture left on the eastern side in the Spokane area. So it's a rain shadow, you call it. It doesn't rain very much or it doesn't snow very much because the mountains kind of stole the moisture. And there's not anything left or much left to the east of it when the jet stream blows those clouds over. It's called a rain shadow. Rain shadow. So we're in the rain shadow of the mountains of California. So by the time the moisture gets over to us, we don't get as much often as they do on the coast. Sometimes there are exceptions, but usually we don't get as much. The mountains, say, above San Bernardino and the Sierra Nevada mountains of Northern California usually get dumped on every winter. And it's great skiing up there in the winter. Not so much to the east in Nevada or here in Arizona. Rain shadow. Did you get it in your journal? A rain shadow where there's not as much moisture left to the east of a mountain range in the United States. So check, I did that, Mr. C. So here we are in a desert and not as humid. And that's why my fingers continue to crack. Mr. C, you don't have your designer Band-Aids on today. I know, they fell off. We've got to put them back on. So our air is pretty dry right now. So lips are dry, skin is dry. Now you younger folks, your skin naturally produces more moisture, so you may not notice it as much. So, but still, we're in pretty dry conditions right now. Arizona's a desert, and all deserts are dry. So here we sit in Arizona. And here in Phoenix, you know we only get that about 8 inches of rain a year. So I might have a true or false question on how much rain we get in Phoenix. So about 8 inches annually or a year. And I'm making myself a little note on that to ask a question about that. So anyway, okay. I wanted to just, I got to make sure I have time to get to that. Okay. So on your tan sheet, you've got a tan sheet, yeah? So on your tan sheet, if you'll write down your hypothesis on this, okay? Now, if you nail this spot on, you can't change your answer. That would be cheating. But if you're spot on any of these answers, you can put your name on your tan sheet and turn it in, circle your spot on answer, and I'm going to owe you something. Not a homework pass. That would be too much high value. Okay, what's the hottest Arizona temperature ever on record? So you're writing it down on your tan sheet in degrees Fahrenheit. Hottest temperature ever in Arizona. Quick, write it down. Pencils down. Hottest temperature in Arizona ever measured? I don't know what year, but way in the past, decades and decades ago. 128 Fahrenheit, 120 degrees Fahrenheit. Okay, if you were spot on, circle that. Okay. Secondly, hottest temperature ever measured in Phoenix. My wife and I were fortunate. Our family was gone. We were out of Phoenix. We were actually in Hawaii when this occurred. And we saw it on TV and went, oh, I'm so sorry that we missed that. Not really. So what was that hottest temperature ever experienced in Phoenix? Maybe 15 years ago, maybe? Guessing. Got it down? Okay, you can't write anymore. 122 degrees Fahrenheit. Hottest ever measured in Phoenix. 122. Okay. Now, I'm going to ask you this on tomorrow's test. What is the boiling point of water, temperature-wise? What's the boiling point? Boiling. This is Fahrenheit and Celsius. So I'm going to ask you both. What is the boiling point Fahrenheit of water? How high do you have to heat it up? So write it down. If you get it, you're going to put a +1. It's another spot on answer. Boiling point of water, 212 Fahrenheit, 212 Fahrenheit. What's the boiling point of water Celsius? Quick, and then you can't write anymore? Okay, we're done with that. So you can't write anymore. 100 C, 100 Celsius. Same deal, Celsius as Fahrenheit. Crossover temperature. Boiling point, 100 C. Okay, now let's do freezing point. Quick. Freezing point of water. At what point does it become ice? or snow. Celsius and Fahrenheit. Put a little F up there for Fahrenheit, a little C for Celsius. Quick, write it in. Freezing point, 32 degrees Fahrenheit. Circle it if you got it right, or spot on. And Celsius, 0 degrees C. 0 C. Circle it if you got it. Okay. Hottest temperature ever in the United States. So write it on your tan sheet. By the way, you're going to put 0 degrees Celsius, 32 degrees Fahrenheit in your journal, right? Freezing point, boiling point, 212 Fahrenheit, and 100 C, boiling point of water. All right, hottest temperature ever measured in the United States was in Death Valley, long time ago. Hottest ever measured, hotter than Arizona's hottest temperature, obviously, because it's the hottest ever measured in the United States. Get it down. Temperature, circle it if you got it right. You can't write it down now. 134 Fahrenheit. Ooh, baby. 134, 12 degrees hotter than the highest temperature ever measured in Phoenix. What's the coldest ever measured? Anywhere in the world. Would it be Antarctica? Of course, South Pole. What was the temperature? This time go Fahrenheit. Just go Fahrenheit. Fahrenheit. Get it down. Time's up. Can't write now. Coldest temperature ever measured, 129 below zero. Minus 129. Minus 129. Wow. That's like a swing, temperature swing of about, I want to get this right, 260 degrees Fahrenheit. From hottest in Death Valley, 134, to coldest in Antarctica, minus 129. Okay, this is more good news. We hardly ever get huge cumulonimbus clouds. This is going to go in your journal. In your journal, we hardly ever get massive cumulonimbus clouds like they do in Oklahoma, Iowa, Texas, Alabama, Mississippi, kind of the middle of the United States, southern United States. They can get really bad weather, super heavy rain out of those super cumulonimbus clouds, super hail out of those really big hail balls. Why don't we get the really severe weather? I'm about ready to tell you. We don't get big tornadoes like they get in those states out of those cumulonimbus clouds. I'm going to tell you why they get them and we don't. Once in a while we get a small tornado. You know, tornadoes are measured from F0, really small, hardly do any damage, maybe 90 mile an hour winds maybe or something. Might tear your roof off. To F5 that can have winds of 200 plus miles an hour, and it'll just destroy houses, flatten them, just flatten them. There's nothing left except the concrete foundation. That's it. So we don't get those kind of tornadoes. Woo, that's good news. Yeah, it's good news. Why not? Here's the reason. And I'll ask you this tomorrow. I'm circling it right now. In Arizona, we usually don't get the clash of warm, moist air running into cool, dry air. We don't usually get the collision of the warm, moist air from the Gulf of Mexico to the cool, dry air from the West Coast. So you don't usually get the collision and then cumulonimbus and then tornadoes or hail balls. We don't get that kind of weather. Hardly ever. It's good news. If we get hail, they're usually pea size, marble size maybe at the most. That's it. Little bitty tornadoes. That's it. We don't get the big hurricanes because we don't get the warm, moist air coming up from the Gulf of Mexico. We don't get that usually. Usually the East Coast or the South gets hurricanes. Once in a while, we'll get the leftovers of a hurricane from Baja, California. And then it only causes maybe 1 or 2 inches of rain because most of the moisture is gone. My wife and I sat during an ASU football game maybe 25 years ago. We knew there was going to be the leftovers of a hurricane that was going to come over during the game. So we had ponchos and umbrellas, and we had like special rain boots, and it poured. It rained about 2 inches during the game. It was fun. It was an adventure. We loved it. We were dressed for it. Didn't get wet. So the football players got wet. They got soaked. I think it was UCLA maybe that played ASU. So anyway, rained quite a bit, but that's rare that we get the leftovers of a hurricane from Baja, California off of the Pacific Ocean. We just usually don't get that. So here's my big question for you. Why don't we get big cumulonimbus clouds with big hail balls or tornadoes? Because we don't get the collision of the cold or cool dry air running into the warm moist air from the Gulf of Mexico and causing tornadoes or poof, 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 or hail balls. So we don't get that violent collision, and that's why we don't get that really bad weather. So good news on that. Or why don't we get the hurricanes? Because we don't get the warm, moist air, super warm, moist air coming off the Gulf of Mexico. We get some of it, and that gives us a monsoon kind of thunderstorm activity increased in July and August, especially down Tucson way, but usually not super bad. So anyway, there you have it. So these videos are posted in Teams. So I think all of you can access these videos. They've been uploaded into Teams. So Triple R tonight. Come ready for your test tomorrow. You'll do well, and Bob's your uncle. So it'll work out really well for you. Mr. Phillip is going to answer any last-minute questions here, any explanations or clarifications. Thank you, Mr. Phillip. Take it away.